All right, let's do a practice example. We're going to talk about an Olympic archer. Fun fact, I have a friend who competes nationally in archery, which is kind of cool. Anyway, this example has an Olympic archer, and she is able, or he in this case, is able to hit the bullseye 80% of the time. Each shot's independent, and if he shoots 6 arrows, what's the probability of the following results? So shooting 6 arrows, each one has the same chance. They're all independent. This is going to be Bernoulli trials. And if we want to know the variable, the value for this exact result, that exact number will be a binomial random variable. Okay, so let X be the number of bullseyes out of 6 shots, 6 arrows. We'd say X is binomially distributed with trials N. N is the number of trials, and success P. We'd write 6. It's a weird looking 6, Jason. 6 with probability of success 0.8. So what's the probability that the first success is the 3rd arrow? So, okay, so this is asking us about the earlier video, all right, with Bernoulli trials. First bullseye comes on the 3rd arrow. That means failure, and then a success, a single ordering. Whereas binomial, right, if we wanted exactly 1 success, there'd be multiple orderings, and we'd have to count them all and multiply things out, or use GeoGebra. But this one we can calculate by hand. That's going to be Q squared. There are 2 failures and 1 success. Well, if P is 80%, Q is 20%. You can just type that into a calculator, 0.2 squared times P. And that's going to equal something. And calculate it all out. 0.2 squared times P is about 3.2%. Is exactly 3.2%. So there's this chance that he doesn't succeed until the 3rd shot. What's the chance that he misses at least once? Out of 6 arrows, right? Remember, this is kind of going back to the beginning. What's the probability that he misses at least once? Well, we're talking about successes. Let's be positive. We're always talking about successes here. So misses at least once, that means hits no more than 5. Right? This is how many failures? At least 1 failure. Right? At least 1 failure is the same as at most 5 successes. So we'll look at what is the probability that the number of successes out of 6 shots is less than or equal to 5. Let's input everything into the appropriate place in GeoGebra. There are now no longer 10 free throws, but 6 arrow shots. And each arrow shot has a probability of 80%. So right there off the bat, you can see the most likely outcome. Most likely outcome is 5 successes for this Olympic archer. But we're asking, what's the probability that less than or equal to 5? Oh, it's going to be pretty likely. So we can do it a couple ways. You can highlight them on the right, or you can use this button. Less than or equal to 5. Type in the 5 here. That's going to be this entire shaded area. 5 or less. 5 or less successes just means that we're not hitting all of them, right? Not hitting all of them is another way of saying we fail at least once. And the answer is going to be down there on the bottom. 73.79%. There we go. What's the probability of exactly 4? Probability of exactly 4 successes. Probability of at least 4. Probability at least 4. You can just type these in. Probability of exactly 4. That's this value right here. You can also sort of cheat it a little bit and say x is between 4 and 4 if you don't want to click. And if GeoGebra is being a little weird. Probability that x is between 4 and 4 is the same as what's the probability x is 4, and it's 24.58%. At least 4 bullseyes, this guy's pretty good. At least 4 bullseyes is going to be, well, 4, 5, or 6. You could say at least 4 is also this, 90.11%. This is most of the area of this graph. Most of the area of this histogram. All right, 90.11%. Pretty likely. Okay, and that's this example. We can even do 2 more parts because they're there, and I definitely didn't forget. At most 4, going to be less than or equal to 4. And how many do we expect him to get? The less than or equal to 4, switch over to here. Less than or equal to 4. Good, it already has a 4. Not that likely, because he's pretty good, so we're not getting the 5 or 6 chance, but 34.46%. And technically all of these should have approximately equal signs. We are approximating all of these. GeoGebra doesn't show us that it's approximating, but it really is. And then expectation and standard deviation are again included up here. The expectation is 4.8. Whoa, no, I don't know where the 0 comes from. Expectation is 4.8 bullseyes, and the standard deviation is 0.9798. All right, so on average, we're going to get 4.8 bullseyes. Wait, yeah, bullseyes. And the standard deviation, so averaging 4.8, but plus or minus 1 on average bullseyes. Make sure the units match the units of our random variable. This is the expected value on the top and the standard deviation on the bottom. And again, this should make sense. What's the, what are we expecting? Well, we're expecting on average is 4.8 or 5, and most of the stuff should be within 1 of that, within a standard deviation. And yeah, most of it is in this region from 4 to 6. So that's kind of conceptually how we can think of our standard deviation. And that's the binomial model. That's how you use it with GeoGebra to answer these sorts of questions. Let me know if you have any more questions, and have a great time doing some math.